Cool. Hey. Hey, guys. Ready to go back home? So, my name is Niran Chen. I am part of the NSBU. I'm NSC and the NSBU. I cover kind of NSX, NSXT with PAS, PKS, Kubernetes in general, and so on. This is Sabha. Sabha, I want to present.
Hi, I'm Sabha Parameswaran with the Customer Zero team. I'm an advisory solutions architect, helping build reference architectures, deployments, and stuff like that.
Customer Zero team at Pivotal, just to be clear, yeah? So Customer Zero, by the way, is a team at Pivotal that helps our customers to provide pipelines and guidance and reference architectures. And Sabha is like the main guy at VMware at Pivotal that knows the VMware NSX stuff. So very good. Okay, so before we kick this off, I don't see anything on the screen here.
I don't know why it's flickering.
Because you're using a Mac. Okay, cool. Sabha is going to kick off a demo. Basically, we have a pipeline that deploys NSXT end-to-end. And Sabha, basically, what he's going to do is we already ran the first step that deploys the OVAs, so it will finish by the end of the session, hopefully. But Sabha will run the next steps, basically, which goes and configures NSX, configures all the virtual routers, the distributed routers that NSX needs for PKS and PAS. And hopefully by the end of the session, we'll have a full green like you see on the screen here, and we can see that.
So I'm just going to kick off the NSXT install pipeline. We are not going to have time to show the whole PKS or PAS install, but the pipelines are out there. That works. So this would be kind of short enough for us to do it during this presentation. So I'm going to kick off a brand new install. Before that, let me show you what we have. So we don't have any VMs up and running on the vCenter. There are no NSX related things. So I did a wipe previously. And if you want to take a look at the wipe is also there. The wipe kind of cleans out all the NSX stuff. I already ran it like 2 times earlier. So you can see it kind of goes through and removes all the T0 routers, all the logical switches and stuff. So everything is kind of cleaned out. And it also makes sure the VIPs are removed and stuff like that. So if there is like a failure with the removal of the NSXT components on the ESXi host, then it actually goes in and clears out the things out and then leaves you the only task of doing a rolling shutdown of the ESXi host. And then you are all clean. So it kind of gives you back your pristine state.
Right, and clean is used for demo purposes, the lab first, obviously. All right, you're kicking it off and moving to the slides?
So let's start off the kickoff. So the parameters are already set. We will talk about the parameters in a second. So it's kind of going through and getting the resources that are required for the NSXT install, which mostly comprise of the OA bits for the NSXT manager, the controller, the edge, along with different pipeline code, other things, the OVF tool. So let's go back to the presentation. So 1 second. So let me show. This is taking forever. OK, so you should see like a vCenter that's pristine. It just has one host. There are no VMs, nothing out there. And at the end of the demo, we should be able to see the whole thing.
It's a bit risky in 30 minutes, but we'll try, right?
Yeah.
All right.
Okay.
So move it forward. Yeah, OK. So just a bit of background about this project, right? Sabha and me started working on this thing in the early last year. Sabha obviously works at Pivotal. Pivotal customers use Concourse for pipelining. We developed in the NSBU, back then it was kind of a hack. We developed Ansible scripts and Ansible runbooks basically to deploy NSXT. And what we did is created a pipeline that uses those Ansible scripts, takes a parameter file that we have, and basically populates the Ansible scripts and runs the books and deploys NSXT. That was, no, sorry. At the beginning was NSXV, right? NSXV and PCF.
So based on Niran's input and a lot of field people kind of having issues with NSXV configuration, so I automated a set of tooling that would help you create the edge in 2 minutes, the whole edge service gateway in NSXV with all the load balancers, the virtual pools, all the things, the firewall rules, the NAT rules, everything in 2 minutes. You basically have the whole edge up and running based on a template you already configured to say, OK, I need to have ops manager on infra, ERT on a deployment. We need all these isolation switches. logical switches, everything. You basically can template it out and say, okay, just bring up the edge for me with these firewall routes. Boom, you have it in 2 minutes instead of going and clicking thousand times in so many places.
But that's history, so we don't do that
was
anymore.
History, and
okay?
then the NSXT comes in and says, okay, how do we do the similar experience? Like one click, you are getting it done in minutes rather than a user kind of spending a whole day or 2 days understanding and clicking through and making mistakes and going back to the drawing board to understand what went wrong.
So we evolved basically the NSX pipeline to NSXT, and the first URL you see in there, right? That's the first URL. Yep. That's kind of the evolution that what we did. This is public. You can take this code and use it for yourself if you want to. But at some point also, and that's the last URL that you see in there, right? Am I looking here?
Yep.
Yep. No, sorry, the second one.
The second one is for PaaS and PKs install.
The last one. Hold on. Okay. The last one is the evolution of that. The NSBU are now developing our own pipeline that's going to be supported through the software lifecycle, coming out with NSX, going through rigorous engineering and QA and all those things. But both are, and that's going to be available pretty soon. Both going to be available for customers. What we see at customers is that either they use the pipelines with us, or they're going to take this code and they break it off and use it for their own good and build their own pipelines with that. The third one, and you can talk about that.
Okay, it's the second one. So the second one is basically the PaaS and PKs install pipeline. The reason we have the third one is me being a Pivotal employee cannot be keeping up with all the changes that they keep pushing out on NSXT. I had been maintaining it solely, and Niran has been providing feedbacks. He had been using it at different customer engagements. But it's best, we thought, that VMware owns the whole thing and can run through the whole management cycles and release cycles and maintain it going forward. And the team has started stepping up and saying, okay, let's actually have a proper public repo with the same fork code and start modifying and adding things.
Right. Now, end of the day, what you need to know is that you need to deploy NSXT manually or with a pipeline, and then you deploy with that pipeline the NSXT CI pipeline, that is the second one, that you can deploy PIS and PKS on top of NSXT. Now be aware there are pipelines to deploy PIS, for example, not on NSXT. Those will not work out of the box to deploy on NSXT, because with NSXT we need to also integrate the NCP, which is the basically the component that communicates with NSX and basically builds all the stuff on the PaaS or PKS, right? So you need to have an adapted pipeline that knows to deploy on NSXT. Let's move on, because we want to get to the meat. We wanted to give you basically in this session as much information as possible about Concourse. I don't know, how many people know Concourse here? Okay, cool. So we'll show you some stuff on Concourse, and Sabha is going to go deep also into kind of how to hack and troubleshoot pipelining on Concourse with those pipelines. This is the next part? Okay, go ahead.
So the Concourse is basically a CI/CD tool helping you deliver repeatable results consistently without any kind of like snowflake efforts. So the normal CI/CD chains, they kind of use long-running VMs. People get into it, SSH into it, start messing up things, doing something else that might leave after effects for you down the line. So with Concourse, it basically everything runs in containers, and it actually provides a very clean abstraction to say, these are resources. Resources can be like files, repos, source code, whatever you want. And then there are tasks that basically operate on those bits to say, okay, I need to convert them, or I need to run tests against them and produce an output that can then be consumed subsequently by the pipeline. So you get the graphical layout that clearly shows, okay, something is green or red or something is still under operating or whatever. And you can basically have fan in and fan out. You can basically trigger things based on changes to the resources or failures on tasks, things like those.
And the nice thing about that is using containers is that you can go in each one of the tasks. If it fails, hijack the container and try to run the script and find out what's going on. Unlike just going through a log and rerunning the pipeline over and over again.
So ultimately, the pipeline is composed of resources and jobs. Resources are basically GitHub resources, a URL resource, a file. It can be S3 resource. So there are a whole bunch of resources out there that are already supported. So you have a get, a put, and check for changes. So you basically have these green boxes which says that it's a successful run versus a failed one. And you can see the inputs are on the side. That says SE lab is the input. The version is an output, candidate release is an output, and version is then used by prepare integration. So you use Concourse by specifying YAML files. So ultimately, everything comes down to YAML description. You basically put it in as a code, check it in and say, this is exactly my flow and how I want you to run my pipeline. So you basically provide all the resources out there. You provide the jobs and the tasks. And everything runs through clean. So in terms of debugging or operating on the Concourse pipeline, you basically register a pipeline. The pipeline would be a YAML file that specifies the job, the task, and the resources. So there's a lot of samples out there for different resources that you want to build on or build a pipeline on. Once you set the pipeline, you unpause the pipeline, provide the parameters, and you start registering and start running with it. And in terms of debugging, you normally try to use something called the hijack command to get into the container, to introspect the environment variables which are wrong, or the files that are wrong, the content is wrong, or the task scripts or something off. The task scripts are entirely up to you. You can have pure shell scripts, you can have bash scripts, you can have Python, you can have Golang, whatever, it's up to you. Basically, the whole thing runs inside a Docker container, and as long as you bundle your dependencies that are required for running those tasks, you're good. So Docker images, like you can create anything, and it would basically pull it from a Docker hub.
So if you build your pipelines as Sabha does, which is, I think, the best pipeliner that I ever met, he puts a lot of tests to check to see what happened and if something worked or didn't work. That means that if something fails, you go and fix your parameter files. Let's say you fat finger the parameter files, which happens a lot, right? You can go and fix the parameter file, re-register the pipeline, and if you put the checks within the pipeline, it will know where to pick it up. If you didn't put any checks, then we'll go through everything again, and you get conflicts, right? So the idea is that you're going to put, for example, you deploy an OVA, make sure you check to see if it's up. Make sure if you can do SSH to it to see if it's actually services are up. Whatever check you can do to see if the task that you wanted to do was done right will make it a lot easier when you go and redeploy over and over again.
So right now, like we are checking on the pipeline, you can see that the controller VM has been deployed. The OI image for the controller VM has been deployed. It's kind of waiting for the IP. And you can see already like there is 1 and 2 and then the manager. So these 3 came up and we still have to go to the edge. So, okay, the controller third one is powered up. So now it's starting the deployment of the controller 3 instance. So this is running as we are talking about. So I had also added a FAQ section in the repo, so you can basically understand, like, okay, I'm using a Docker Compose to run Concourse. I'm not using full-blown Bosch deployed Concourse, so I don't know how many of you are aware of Bosch. So a few fans of Bosch and Concourse, but then there are people who are like, okay, I just want to bring up a very simple standalone instance of Concourse or use a Docker image to bring up Concourse. So there can be different things, like if there's a proxy in the middle, then things might not exactly work as is. So I had put in FAQs to explain the thing, like what trouble pain points you might actually hit and what would be the solution, where to look for, things like those. And also, with NSXT, the static routing and BGP is a little bit like a black magic. So I had tried to explain a little bit about static routing for people who are going for the static route. We will talk about that later.
Well, yeah, okay. So one. Everybody knows what NSXT is, right?
It's like overflowing from you.
Yeah. Let's move to the next slide. Let's focus on the code here. So the pipelines. I'm going to talk about the NSXT pipeline that we're doing in the NSBU, and then I'll let Sabha talk about the PAS and PKS. Just to let you know what I usually do in my lab when I test those pipelines, I basically deploy NSXT with a pipeline, and then I deploy PAS and PKS on top of that. And I have the parameter files ready already with all the configuration to lay over on that. So a deployment for me of the whole stack is basically 3 clicks. That's the power of using those type of pipelines. It leaves you not only with a repeatable process of deploying the software, it also leaves you with documentation what's going on exactly with your deployment, right? You know, you can take that parameter file and use it as documentation. The best shops that I've seen that do DevOps, they continuously update the repositories of the pipeline files and the parameter files. They always have the most up-to-date and version in what's going on with the pipelines. No, specifically about, okay, go ahead.
The way we do it is like he fat fingers something, he will call me. I will kind of debug into the thing and say, okay, you messed up this parameter. Or he will say, can we add this option to have the compute cluster separate from the management plane? And then I'll start working on the code. I check it in. And then all he has to do is click plus, run a new instance, boom, he has a change. We are working truly distributed.
Yeah, those are the good days when it wasn't in the NS view under the rigorous processes of software lifecycle. Right now, it's a bit harder for me to add changes, but at least it's supported by the view. Let me talk about this, right? So no, go back to this one, yeah. So just to explain what this pipeline that we're building right now in the NS view does. It does everything from 0 to 100, right? What we need to make stuff work, like PS and PKS on NSXT, is we need to take care of routing. That's one main thing that you need to do. We need to deploy the bits and tie it all together. So deploy the OVA, deploy the edges, deploy the controllers, make sure they all work together, and then deploy all the logical constructs that the PAS or PKS will take advantage of. We try to offload as much as possible work into the PAS and PKS pipelines that the Pivotal are creating from their deployment, so that the NSXT deployment is going to be easy and simple as much as possible for our customers. If they want to use it for PAS or PKS, if they want to use it for something else, you can always augment the parameter file to make it work, right? So we deploy, as I said, the OVAs. We go through all of the installation, and then we create all the tier 1 routers, the NAT rules, the load balancers if it's PAS, right? We change the certificate on NSX Manager. We basically do everything so that it fits in the reference architecture. The one thing that is going to, so from a routing perspective, we currently support only AJ VIP and static routes. We're going to add BGP capabilities in a later stage. So if you guys doing any BGP, you may need to do, if you want to use the pipeline, you may need to develop your own additional script just to do that, or you deploy the pipeline and manually fix the BGP, change the BGP. That's it's not a big deal. Most of the problems, just one second. Most of the problems that we see in the field with NSXT deployment is misconfiguration on the physical side, not on the virtual side. It's very easy to fix stuff when it comes to NSXT. If someone, for example, using static routes and didn't put the right route or created something that's already configured somewhere else on the network or misunderstood the way it works in NSXT, we found ourselves working for a few hours just fixing the routing. And that's if we have access to those switches, right?
Just to show a quick update on the pipeline. I'm logging into the NSXT, which just came up. And OK. So we can check on the dashboard. I don't know whether the control plane of it has started coming up through. So you can see the cluster connectivity is down. Can you guys see it, the red one? The cluster connectivity is down. The manager, all the controllers have connected to the manager, so it's kind of still in progress. So we should see this join all together in the cluster.
We've got 12 minutes.
Okay, so
time for questions. So let's
sure.
let me run through this, and you can go into your stuff. Okay. Click next. All right. So the NSXT pipeline that we're building is based on basically a Docker image that's going to be in Docker Hub. You run the Docker image with a few parameters so it knows. So what it does basically, it downloads, it runs the script that deploys NGINX. It copies the OVA of the NSX manager. It copies the OVF tool that needs to deploy the OVA manager and puts them in a local folder so it can be served through the NGINX server, right? And then it goes and deploys Concourse for you just for the purpose of deploying NSXT, though you can use that later if you want to. And then it goes through, register the pipeline, and all you need to do is go to a web server, click plus, it will run through the pipeline. Obviously, you need to do the parameter file. That sometimes, you put a wrong parameter, something doesn't work. Jeff knows this. We've been through this. So what you need to do, basically, you need to go and update the parameter file, exec into the container that runs the script, and do fly reset. We called it, basically runs fly register pipeline again. Yeah. Okay, cool. Last thing, we also adding sample parameter files for supporting PKS, PAS, or both, right? So if you deploy in PKS, you're going to have the sample parameter file with the tier 1 router that's required, the pools that are required, and the NAT rules that are required in it.
So to kind of make things easier, I broke it out into 3 steps. So one is just deploying the management plane, the NSX controller, the manager, and the edges, make sure they are all joining together. So that can be done separately. And then you come in and say, okay, I'm ready for the next step, which is adding the routers, the logical switches, and whatnot, the IPAM pool or other external SNAT pool and stuff. So those can be done separately, or you can re-trigger them with modifications, or you want to add more new pools. So those can be done again. And then the final step is to kind of expose load balancers, NAT, or like self-signed certs. Okay, so I think, so the install part is done. Basically, we have got the management plane up. So is it green now? Yes. It is fast. I use GovC rather than OEF tool. So that was basically bringing up the management plane. So that is done. Let's look at the next step. So even the next step. So I might have to trigger it, this one, separately. So let's run through the thing. So right now there are no logical routers, no T0 or T1 routers, and we've just fired it off. And also in the fabric, we don't have all the nodes or anything. So it's starting to add the transport nodes. So the whole thing is automated for you. As long as you provide the right parameters, you should be getting a consistent result of a working NSX setup all under 20 minutes.
Just one note about adding the right parameters. If you do a manual deployment of NSXT, you may make it faster than doing it with automation, because with automation, you got to make sure the parameter file is right, and you need to go back and forth. And sometimes you need to just redeploy over and over again a couple of times until you get it right. But as I said, you're left with a repeatable process and some documentation of what's going on. Whereas with manual installation, you control what you do when you deploy it. So just our experience, always I would suggest using the automation if you can. Just makes life easier after you get it right.
So it has started adding the ESXi host. The edges are already added. So if you check under the thing, under the host, so let's give it a second. So going back to the presentation, any questions so far? Are people kind of tired after the lunch? Okay. So this is the basic steps for using the whole pipeline. You provide a set of parameters that specifies what is the vCenter connectivity, what are the endpoints, where do you want things to be deployed, what are the IP pools and stuff. You provide the GitHub repos that already has the pipeline templates and the samples and stuff. It also uses Ansible under the covers. And then you also provide a NSXT install bits. So this particular version of the pipeline didn't really have a capability to go out to my.vmware.com and download the bits. And then you basically have the vSphere environment, and at the end of the day, you basically get NSXT, not even end of the day, in half an hour. And this is a whole fully installed pipeline wherein you install the management plane, configure the routers, configure the extra configs like NATs and load balancers and route distributions. So this would be the breakdown of the steps in the basic install. You deploy the OVAs, set up the managers, the controllers, the edges, form the management plane. So this is what you get at the first step. So you get the controllers, the managers, and the edges. You get this dashboard we saw where the cluster connectivity was down, and then it became green. And then the next step is to add the routers. It basically creates the T0 routers. So let's take a quick look at the T0 routers. So
will this presentation be available for attendees? Yeah.
So we have got the T0 routers now. So let's look at the logical switches. So the logical switches have been created. So since this one was using a template that was specific for PKS, we basically got the PKS infra and PKS services. It can be whatever you want. And the whole thing is in YAML. It's pretty straightforward for you to kind of configure what you want. So this is like a definition of the T0 router. You can say active and standby, what IPs to use for the VIP versus the edge 1 and edge 2. And then you can go in and say, these are my logical switches, the HA profile IP block, external IP pools. So this whole thing, you can basically just create it by hand. There is nothing special to like call an API or anything. You just specify what you want, you get the result.
Let's take questions.
Okay.
Any questions? Because we have like 4 minutes.
No, no. We expect you to have already prepped it and stuff.
Yeah, there are ways, obviously, to deploy an ESXi automatically. You have auto-deploy capabilities. You can do it with, you can bootstrap that with Pixie Boot, right? There's different ways to do that. Are you looking to deploy the whole vSphere stack as well automatically? Yeah. Yeah, we have a few customers that asked basically the ability to deploy the vSphere and then deploy NSX and stuff on top of it, so everything is automated. We're looking to help them with that, but yeah, it shouldn't be a big issue.
So essentially, we have got the whole thing configured now. Was it like under 20 minutes?
No. Okay.
And,
Any other questions?
Which one?
I think this is 314, something like that. Concourse, Sabha.
Concourse was 314, but it would work with 4 dot or whatever.
Yeah, okay.
And
we actually, the NSB, we forced it to be on 3. I found some things on 4 that weren't like, but yeah.
Okay.
Can
I didn't recognize the tabs up in the top.
Okay. Yeah, they have a little different outlook, yeah.
But that's 3. That's
Yeah, what I'm running now is 3.14.
Okay.
So this is a quick look into the past pipeline. We don't have the time to deploy it. Basically, the pipeline is auto-configured for NSXT, so it goes into the BOSH deployment, the vDirector configurations, and says, okay, configure it for NSXT integration and with NSXT mode enabled, and then it also deploys the NSXT add-on tile, and then sets the parameters for the past tile to say, use external container, which would then default to NSXT. So it runs through the whole thing. And these are the tile configurations you would see in any pivotal docs. And this would be the routing distribution of the topology. You basically expose the ops manager with the external IP. For the Go router, you would use a load balancer. It's pretty much straightforward. The template takes care of already pre-configuring the IP pools, load balancers, and things like those when you do the NSXT install. So the similar way for PKS, so you don't have to go in and say, okay, how do I connect to the PKS controller? It's automatically would open up a NAT rule for you to connect from the outside. The same way for Harbor. And it also says, okay, you basically have this IP pool. So let me grab the GUID from this, the GUID for the T0 router, plop it down on the pipeline instead of you doing this. Dump here, copy this GUID, drop it here, go keep going back. None of those. The pipeline takes care of it automatically. It also creates the PKS user, so everything is auto ready. Like you are done with the pipeline, you are ready to start working on the cluster. I think that's about it. So you do have the references to the various links. You can check my blog site that has information about all the different products and stuff, or different installs or pipelines.
Any other questions before we finish? Yes.
No, it would be downloadable, right?
Yeah, yeah. I'll send it over.
Yeah. The lesson I learned was like, if you have to do the same thing twice or thrice, better to automate it. And there are some people who might say that, okay, Concourse is not the right tool for automation, but I found it easy because it can kind of grab the right bits for me, the Docker image or the OVF tools, and put the Git thing, and you basically have like a quickly built Lego piece that can do the job for you.
That's a great point, by the way. There's, for NSXT, there's Ansible scripts that are public right now, developed by the NSBU, the books to deploy NSXT. There's also a Terraform provider just for NSXT. And you can use anything you want, obviously, with the NSXT API to do it yourself if you want to. But there's a lot of it already out there that you can utilize, whether it's Concourse, Ansible, Terraform, all that.
And the other one, I don't know, I don't think anyone noticed was we actually didn't go online. We used actually tarballs of the Git repos, the Docker images, and everything. So this whole thing can run in offline mode. So you can dump the bits into a S3 blob store, run through the thing. The same thing for PKS or PaaS pipelines. So in like an highly secure environment where you don't really want to go to Docker Hub. You don't want to go to online GitHub repo. You can basically use a tool called CanPKS. We have a special offering of that. So that would basically download the bits that are required, dump it into S3, and then you are ready to go, OK, here is the bits in this blob store on this VM or something, and point the pipeline to it. The pipeline basically has an offline version of it. So it says, OK, extract these bits from here and start running as it was in an online environment.
We're out of time. So
Okay.
Sabha's going to stay here to answer any questions you have. I got to run to the airport. Good seeing you all.
Thank you, Niran.